This is key to topic 29, worksheet 3. And number 1, the function is this, and let me go ahead and write it on here to make it a little bit clearer. You have f of x equal e to the x minus 2. All right, and so you want to find the value of f of 2. So let's go ahead and do that. So this is part A. So part A, remember f of 2 indicates you go to your function f, and where we see the variable x, you substitute 2. So this becomes e squared minus 2. Now notice it did say round to 4 decimal places. That's 4 digits behind the decimal point. So in our calculator, and make sure you use your calculator's e function. So you're going to say, in my case, you're going to say second ln, all right, and you're going to say, and I think we said what, 2? So that's 2. Make sure you put parentheses because you're going to be subtracting something, so that's important. So do this, and then subtract 2 equal, and you get this number. So I'm going to get, I'm going to go ahead and write it out. So 5.3890560, and so on. For decimal places, 1, 2, 3, 4, that's here. So tenths, hundreds, thousands, 10,000s. So I got to round to the 10,000s place. So I got to look at the 100,000s place. And since it's 5 or bigger, since 5 is 5 or bigger, the 0 becomes 1. So it's important you round correctly. So 5.3891. Okay. Part B, you want to find f of negative 1. So same idea. So you're going to say e to the negative 1 minus 2. Now we're going to use your calculator. Use a calculator. Make sure you know how to use your calculator. So second ln to get to my e function. It puts a parentheses. So the exponent's negative 1, so put negative 1 here. Make sure you close it this time because you're subtracting 2. So if you don't close it, you're doing this and you're not going to get the right answer. All right, so you got to close this. And now subtract 2. So your calculator is going to do this first, and then whatever that is, it's going to subtract 2. Okay? And then you get this number. So you get negative 1.6321205, and so on. So 4 decimal places, 1, 2, 3, 4, that's here. Since 2 is less than 5, the 1 stays 1. So this becomes negative 1.6321. All right, C, you want to find the domain of the function. So you're going to find the domain. Well, remember, this is an exponential function. The domain of all exponential functions is all real numbers. So it's negative infinity to infinity. You want to find the range. All right, now here's what you got to think about. So in your mind, and this is important to do the range, because remember, in your mind, you have this exponential function. An exponential function has a horizontal asymptote. The horizontal asymptote is this number right here, negative 2. Okay, so that's negative 2 right here. And since the graph, you see there's no reflection, right? So there's no reflection about the horizontal asymptote. There's no negative out here. And so that means that the graph's going to be above it does not necessarily go through the origin. I just drew a quick graph. So you know the graph's going to be above, right? So it's going to be from negative 2 to infinity. Remember, the graph on this side gets closer and closer and closer to the horizontal asymptote without touching it. So it's getting closer and closer to negative 2, negative 1.9999, and so on. On this side, it rises very rapidly. And so it's an increasing function. So you remember, you go from left to right. So as I go from left to right, my y values are increasing. So it's an increasing function. So this is an increasing function. Just keep that in mind. You learned that in your lessons. So the graph, whether it's increasing or decreasing, the graph is above the horizontal asymptote. So the range, you're going to say negative 2 to infinity, with parentheses around negative 2, because remember the y value is never negative 2. It gets closer and closer to negative 2 without being negative 2. So that's why you see a parentheses here, not a bracket. All right, E, they want you to find the horizontal asymptote. Well, we just talked about that. The horizontal asymptote is this horizontal line. Remember, though, when naming the horizontal asymptote, you got to say y equals negative 2. All right, F, it says this. It says, is f an increasing or decreasing function? Well, we already talked about that. Okay, so listen carefully. the graph is above the horizontal asymptote. We know that. E, so here's what the next thing you got to look at is the base. The base is greater than 1, right? Because E is approximately equal to 2.718. Since the base is greater than 1 and the graph is above the horizontal asymptote, it's going to be increasing. So this is an increasing function. Okay, increasing function. Since the base is greater than 1 and the graph is above the horizontal asymptote. All right. Okay. G, they want you to find the y-intercept. Well, remember, to find the y-intercept, you let x equal 0. That's always, the y-intercept is always easy to find. You let x equal 0. So you get y equal e to the 0 minus 2. So y equal e to the 0 minus 2. So where we see the variable x in your function, you substitute 0. Well, we know from previous courses that e to the 0 is 1. 1 minus 2 is a negative 1. So my y-intercept is negative 1, or you can say 0, negative 1. All right? And so that's number 1. Now, that's all they want you to do, is just to give that information. All right? So let's look at number 2. Number 2 this time, we have this function in number 2. Okay, number 2, we have this. We have g of x is negative e to the x plus 3. E to the x, negative e to the x plus 3. All right, so you want to find in A, you want to find the value of f of 2. So remember what that means. That means that you want to find y when x is 2. So you're going to let x be 2. So I get negative e squared plus 3. And then let's use our calculator because you've got to round to 4 decimal places. So remember, it does say, see right here, 4 decimal places. So on your calculator, though, be careful. On your calculator, you see it has negative e squared. So you got to put that negative first. So negative, see your negative right here. See right here now. And then second ln. So there you go, negative e to the second power. Close the parentheses. You got to close it because of that plus 3. So now the calculator is going to do this first, and then whatever that is going to add 3 to it, and you get this. So I get negative 4.389056, and so on. So the 4 decimal places, 1, 2, 3, 4, that's this. Since this 100 thousandths is 5 or greater, then the 0 becomes 1. So this becomes approximately equal to negative 4.3891. All right, B, you want to find f of negative 1. Same idea. You're going to say, well, that's going to be negative e to the negative 1 power plus 3. So in your calculator, you got to press that negative function first. So that's this. All right, and so I get second ln e to the negative 1, close that parentheses. Okay, so the calculator is going to find this first, and then whatever that is going to add 3 to it, and you get this. So let's see, we get 2.632120.5, and so on. So the 4 decimal places, 1, 2, 3, 4. You got to look at the 100 thousandths place. And since this number is less than 5, the 1 stays 1. So that'll be approximately equal to 2.6321. All right, C, you want to find the domain. All right, well, remember the domain of this function, is, since that's an exponential function, the domain of this function is all real numbers. Okay, all real numbers. D, you want to find the range. And then in E, you want to find the horizontal asymptote. All right, so let's do it this way. So here's what we know. We know that in our mind, we know that the horizontal asymptote is y equals 3. And I'm sorry about this. I said f of 2. This should be g of 2 right here. G of 2. So that's g of 2 because our function's g. Sorry about that. So that's g of 2, g of negative 1. All right, so be careful. All right, so the horizontal asymptote we know is this constant, so y equals 3. Okay, and so I know it's here. Now here's, to determine the range, here's what you're going to say. Here's what you're going to ask yourself. Is the graph above or below? Well, there's a reflection. So I'm reflecting this graph about the horizontal asymptote. So instead of being above, it's going to be below. Okay? So the graph's going to be below the horizontal asymptote. All right, because of the reflection. Now here's what you got to think of. So I know the graph is below, right? Okay, so I know the graph's either going to be increasing or decreasing. Well, we're going to talk about that in a little while. So I know the graph's going to be increasing or it'll be decreasing. But regardless of whether it increases or decreases, the range is going to be from negative infinity all the way to this horizontal asymptote. And remember, the horizontal asymptote is y equals 3. And so I'm going to say negative infinity to 3. Now remember, no bracket because remember, your graph gets closer and closer to the horizontal asymptote without touching it, without crossing it. So y is never going to be 3. You're never going to have a y value of 3. The y value is going to get closer and closer to 3. So 2.999999 and so on. So that's why you have a parentheses there. Okay, and then in part F, you want to ask yourself, now is it increasing or decreasing? Okay, now remember, I'm gonna change this to F here because all these are F's. So I meant, see, this should have been either f of x or g of x, and all these should have corresponded. So it's easier just to change this to f of x. So now that you want to find, is f of x increasing or decreasing? All right, so let's talk about that. So remember, if there was no reflection, okay, then this graph would be above the horizontal. Since the base is greater than 1, it will be an increasing function. Okay. There's a reflection though. All right, so let's talk about that again. If there's no reflection, cover this up, then the graph is above the horizontal asymptote. Since e is greater than 1, it'll be increasing. So in our mind, we know it does something like this. The reflection reflects it about the horizontal asymptote. So instead of increasing, it is decreasing. So this will be a decreasing function. Okay, so decreasing function. And then in part G, you want to find, so it's decreasing function since, let me go ahead and write it out, since the graph is below the horizontal asymptote and the base is greater than 1. So since the base is greater than 1, remember in our mind, this is what we have. Okay, so if we cover this up, then the horizontal asymptote is y equals 3, and we know the graph's going to be above the horizontal asymptote, right? And since the base is greater than 1, it'll be an increasing function. Since there's a reflection now, instead of doing this, it'll do this. So then it'll be a decreasing function. So make sure you understand what I just said. So that's why the answer to G, that's why the answer to F is a decreasing function. All right, now they want you to find the y-intercept. So to find the y-intercept, you're going to let x be 0. So we're going to say y equal. So remember, you just g of x or f of x, whatever this is. I got to fix it, but this is y. And you're going to say y equals negative e to the 0 plus 3, right? Negative e to the 0 plus 3. E to the 0 is 1, so that becomes negative 1 plus 3, which is 2. So the y-intercept is 2, or you can say 0, 2. Okay? All right, so that is the key to topic 29, part 3. Okay?